A strange voice from deep space. A mysterious object named 3IATLAS has just sent a signal.
Only 3 interstellar visitors have ever been confirmed in our solar system. The newest, 3IATLAS, just spoke in radio with a quiet chemical signal that settles the debate about its nature. South Africa's MeerKAT radio array detected hydroxyl absorption lines at precisely the frequencies Comet scientists expect. That is not a beacon. That is sunlight turning buried ice into gas and leaving an unmistakable molecular fingerprint. For a rare interstellar comet, this is the clean, testable way to separate speculation from physics. Here is the big picture. 3IATLAS, also catalogued as C2025N1 Atlas, was discovered by the Atlas survey in early July. Its orbit is hyperbolic, not closed, which tells us it came from beyond the Sun's family and will not return. It raced through perihelion around October 30th and continued outbound on a one-time pass. This places it alongside Oumuamua and 2I Borisov as the only confirmed interstellar objects seen up close, and it gives us a tiny but growing sample to compare. For planetary science and astrobiology, each new case matters because it widens the chemical and dynamical diversity we can measure. Before the radio detection, visible light observations already pointed toward a natural comet. Telescopes recorded a diffuse coma and a short tail, both classic signs of outgassing. Brightness changed with viewing geometry and solar heating, just as it does for volatile rich nuclei. The visible story was persuasive, yet cautious researchers wanted stronger chemical proof. Radio spectroscopy provides exactly that, because molecules announce themselves at very specific frequencies that can be checked from Earth with high precision. The decisive measurement came when MeerKAT recorded absorption by hydroxyl at the main lines near 1665 and 1667 MHz. Hydroxyl is the daughter product of water. Sunlight hits water molecules, breaks them apart, and newly formed OH imprints narrow features in the radio spectrum at known frequencies. The signal shows the right shape, the right Doppler shift for the comet's motion, and the right timing near peak activity. That is the chemical receipt linking water sublimation to a real object in space. It is exactly what comet radio studies have found for decades across the solar system, now seen from a body that started around another star. This is why engineered transmitters are the wrong fit. Artificial signals are usually ultra-narrow and often carry modulation or drift patterns that reflect a design choice. The OH features from 3IATLAS are molecular transitions with thermal and kinematic broadening. They live at fixed frequencies set by quantum mechanics, not by an engineer. The optical context does not require technology either. A dusty coma and a faint tail are natural byproducts of heating. To claim otherwise, you would have to explain why a craft would imitate comet chemistry down to line-locked transitions while also releasing dust that mimics sublimation. The simpler model already fits all the data. It is fair to ask whether anyone listened for technosignatures. The answer is yes. Groups that routinely search for narrow band beacons did monitor the target during favorable windows. No engineered carriers were reported. In science, you do not declare the impossible, you quantify the improbable. With current evidence, adding hidden technology to a working comet model is unnecessary and unsupported. Occam's razor is not a slogan. It is a practical rule for building models that explain the most with the fewest assumptions. How did MeerKAT pull this off for such a faint target? MeerKAT is a 64-dish interferometric array with superb sensitivity in the L-band where the OH lines reside. Arrays like this stitch together many antennas to act like a much larger instrument for spectral line work. When a comet's gas cloud lies in front of a background radio field, OH can siphon out a sliver of that background at 1665 and 1667 MHz. That creates an absorption dip rather than an emission spike. Same molecule, different observing geometry. The sign of the feature is set by contrast, not by whether the chemistry is real. The timing also makes sense. Ephemerides and public briefs for 3IATLAS flagged the safest approach distances and visibility windows around perihelion. Those are the days when solar heating is strongest, gas production ramps up, and radio lines are most detectable. Optical teams saw the coma development, and radio teams aimed at the OH lines while activity was near peak. Independent reporting by reputable science outlets captured the detection details, and explained how a molecular line is different from a message. Convergence across instruments and outlets is a reliability check. It is not proof by headline. It is proof that many eyes measured the same physics. Open questions remain, and that is where the science gets exciting. We still do not have a complete volatile inventory. Interstellar comets can carry unusual mixes of carbon monoxide, carbon dioxide, and complex organics. Those species turn on and off as different layers warm. Dust size and ejection speeds are also evolving targets. Small transient jets could have shaped the short tail at times. These are familiar challenges from solar-borne comets. Interstellar status does not rewrite the playbook. It widens the sample and forces models to work across a broader range of conditions. Comparisons help. 2I Borisov looked like a classic comet, rich in gas with a substantial coma and tail. Oumuamua lacked a visible coma and showed non-gravitational acceleration that sparked many hypotheses about exotic ices or unusual geometries. 3IATLAS slots in as a cleaner chemical case. It gives us water family lines, dust, and a normal-looking coma, all wrapped in an interstellar trajectory. With 3 data points, we can begin to ask population questions. How common are water-rich interstellar comets? How often will we see CO-driven activity far from the Sun? What fraction will present bright radio lines near perihelion? There is also a public responsibility piece. Rare visitors invite extraordinary claims. The responsible way to explore them is to check extraordinary claims against ordinary physics first. Ordinary here does not mean boring. It means sunlight, ice, dust, and gas following known rules, observed with instruments that can discriminate between molecules and machines. The wonder is not diminished when a signal turns out to be chemistry. The wonder is that a comet born around another star can waft past Mars and Earth and leave a readable line at a frequency that tells us water once locked in a nucleus is now a cloud of OH streaming into space. What should we watch next? Community campaigns coordinated through the International Asteroid Warning Network are running through late January to gather more astrometry and to refine models. Continued L-band work can track how the OH column changes as the comet recedes. Infrared spectrometers on large telescopes will probe carbon monoxide, carbon dioxide, and organics to map the volatile budget. Photometry can monitor dust production rates and look for any late-time outbursts. Every new measurement reduces the wiggle room for exotic explanations and adds texture to a young field called interstellar comet science. For viewers who care about searchability and discoverability, here are the phrases that reflect the evidence-based story and help other learners find it. Interstellar comet 3IATLAS confirmed by radio detection. Hydroxyl OH lines at 1665 and 1667 MHz. MeerKAT radio telescope L-band spectroscopy. Cometary coma and dust from water sublimation. Not an alien object, no technosignature detected. Outgassing near perihelion and safe miss distance. Comparison with Oumuamua and 2I Borisov. Planetary science, astrobiology, and spectroscopy. These are not buzzwords. They are the backbone of what was measured and why it matters. The takeaway is simple and strong. From first images to first radio lines, the chain of evidence tightens into a coherent picture. 3IATLAS is outgassing water family molecules and dust like a textbook comet, only the textbook is interstellar. MeerKAT's detection of OH at the main lines is the clean chemical proof that ties sunlight, sublimation, and radio physics together. There is no narrow band beacon, no structured modulation, no message. There is natural chemistry unfolding at interstellar speed. That is not disappointing. It is profound. Other stars are sending us icy messengers built from familiar ingredients, and our instruments are now precise enough to read the faintest handwriting in the dark.